going to show you a good strategy for dealing with questions like this. If we take the number 547, then we could write it as 5 times 100 plus 4 times 10 plus 7 times 1. This is what I call powers of 10 form. And we can actually do that with our general number ABC, a 3-digit number. Now, just to show that it's not A times B times C, I'm going to put a little bar above it. That is occasionally used as notation. I've seen it on UKMT and elsewhere. And I'm going to do exactly the same thing, write it in powers of 10 form. So it's 100A plus 10B plus C. So now, if I have the sum of this number, that's 100A plus 10B plus C, and I add the 3 individual digits, A plus B plus C, then I want it to equal 429. And I'm just simplifying it now, I've created a Diophantine equation. There are 3 unknowns, but they're all whole numbers. In fact, this case, they're all between 0 and 9, except A, which is between 1 and 9. It can't equal 0. Obviously, it can't equal 9 because it's way too big. So we can very quickly work out what A is. So 101A plus 11B plus 2C must equal 429. Okay, so the only way this can possibly happen with them being digits between 0 and 9, remember B, this here is going to have to be less than or equal to 99 plus 18, because that's the largest that B and C can actually equal, which is 117. So there's no way that A could actually equal 3, because I would get, so if A equals 3, then I'd get 300, and it'd be less than or equal to 303 plus 117, which is 420. So A is going to have to equal 4 for this to work. And that means that hopefully that makes sense. It can't equal 1 or 2, that'd be way too small. It can't equal 5 because that'd be too big. So it can only equal 3 or 4, but I found the maximum that this can equal, so it can't equal 3. We could never reach 429. A equals 4, we get 404, which means 11b plus 2c is going to be 424 minus 404, which gives 25. Okay, I've managed to simplify this greatly. I'm going to put a little box around that. Right, let's think about this now. So if this number is necessarily even, actually, so it must be that B is going to be odd. Because if B is even, we'd get an even plus an even, we'd get an even. So B is actually going to have to be 1. It can't be 3 because then it would be too big. And that, yeah, it can't equal 2, like I said, because then we get 22 and we'd have 2C equal to 3. So that means that 2C is going to be 25 minus 11, which gives 14. And there we have it. C is equal to 7. So you can do this question without using algebra by thinking for it carefully, like convincing yourself that A is 3 and going from there. But this is a nice kind of algorithmic way using the idea of Diophantine equations. So our number originally must have been 417, and then we added 4, 1, and 7. We can see that that does check out to give 429. So the product of the 3 digits is going to be 4 times 1 times 7, giving us 28.